3. Let's get started. Question number 1. A closed surface contains two equal and opposite charges. The net electric flux from the surface will be. So this concept is taken from the Gauss's law, according to which net electric flux from a surface is equal to the total charge enclosed by a closed surface divided by epsilon naught. As we are told that the closed surface contains two equal and opposite charges, consider one is positive charge, another one is negative charge. As both charges are equal but opposite, so the net charge will be 0. So according to this, the net electric flux from the surface will be also 0. We have the correct option is option A. Now let's see the question number 2. A parallel plate capacitor is completely charged and a battery is detached from it. Then a dielectric slab is inserted between its parallel plates. Which of the following options is correct with respect to potential difference and energy? This MCQ is taken from the energy stored by a capacitor, and we are familiar with the formula for the energy stored by a capacitor, which is equal to half Q times V. Dear students, keep in mind that whenever you insert a dielectric slab between parallel plates of a capacitor, the potential difference also always decreases. So in correspondence to this, as the potential difference between those plates decreases, then the energy between these parallel plates also decreases. In the year 2023, the options which were given for the MCQ number 2 were not correct. Those MCQs were misguiding. So I have figured out and fixed the MCQs, and I have corrected the MCQ. Now for this, the potential difference in energy both decreases. So our correct option is option C. This is the option I have fixed because in previous year they have mentioned that the energy remained constant, but that is not correct. The correct option is that both potential difference in energy both decreases. So the correct option is option C. Now let's move on to the question number 3. If two capacitors of 10 microfarad each are connected in series combination, then their equivalent capacitance will be. Again, this is a very simple MCQ. You are just given two capacitors, each of 10 microfarad, which are connected in series combination, and you are to find equivalent capacitance. If you are familiar with the formula to find equivalent capacitors for series combination, you are good to find the equivalent capacitance. Just using the formula for series combination and putting the values, we get the answer is 5 microfarad. So our correct option is option C. Now let's see the question number 4. Due to electric polarization of dielectric, the capacitance of a parallel plate capacitor. So this is a conceptual question from the topic capacitance of a capacitor. And whenever you insert a dielectric slab between plates of a parallel plate capacitor, we know that the capacitance of that parallel plate capacitor always increases due to the electric polarization. The dielectric reduces the effective electric field, which reduces the potential difference between the parallel plates of a capacitor, which causes the increase in the capacitance of a parallel plate capacitor. So whenever the dielectric slab is inserted between plates of a parallel plate capacitor, we get the electric polarization, which returns the increase in the capacitance of a parallel plate capacitor. Now let's see the question number 5. In the given diagram, 3 capacitors are connected in an electric circuit. Their equivalent capacitance will be, again they are asking the equivalent capacitance. Now this time we have to figure out whether the capacitors are in series or in parallel. See the figure that it is clearly showing that the capacitors are connected in parallel. So all of 3 capacitors are in parallel combination. Simply using the formula for equivalent capacitance in series combination, you are very fine to find the equivalent capacitors. So we have 3 capacitors, one of 1 microfarad, second one is 2 microfarad, third one is 3 microfarad. Just summing all of these capacitances, we get the answer is 6 microfarad for the equivalent capacitance in the parallel combination. So our correct option is option D.